When using NAT, which translates between public and private IP addresses, we can redirect traffic that's externally initiated to particular computers on our internal network. Now, there are two ways we can accomplish that, both through the RAS console. So here we've got NAT set up. Local Area Connection 1, so to speak, is our public interface. And the public interface is where you do all your configuration. And the private interface, just to recap here, really has nothing. It just says it's the private interface. It does have packet filters, as do all connections coming in and out of RAS. We also have properties at the NAT level, at the server level, where the server can be a DHCP allocator or DNS server. What we're going to focus on here is the public interface and configuration of the public interface. You want to be very careful that logically here we are saying that this interface is the public interface. You also want to make sure that the corresponding physical interface is the public interface. So you want to be very careful about that. Now in this scenario, we're just enabling NAT. We're not worrying about the firewall, which is basically ICF, by the way. What we're going to look at here is the address pool tab. Now on the address pool tab, we specify the public IP addresses that have been assigned to us by our ISP. As an example, I'll go ahead and click on Add, and we'll just make up an IP address range here. Okay, so this assumes then that our ISP has assigned us 4 public IP addresses. So .20 through .23. Now, of these 4 IP addresses, what we can do is we can redirect all requests going to a particular IP address to a particular internal computer. That is, we can make a reservation. So we can reserve one of these 4 public addresses exclusively for the use of a single internal computer. Let's go ahead and set that up. So a reservation here, and we're going to reserve .22. So we had 4 addresses, .20, 21, 22, and 23. And we can reserve .22 for a particular internal computer. So again, what we've done here in the address pool tab, our ISP has assigned us 4 public IP addresses, which we have defined here. We've reserved one of those IP addresses for a particular internal computer. So any external requests coming into .22 will be redirected to this particular internal computer. Now, one of the reasons we do this is to hide the internal addresses from the internet. So people on the internet would not know that that is the internal private IP address. And keep in mind that any request to .22 would be redirected to .243, the internal computer. Another way to redirect incoming requests is something called a port mapping. With a port mapping, you could say that any traffic coming in on a certain port number will be redirected to a particular internal computer. Let's say behind the NAT server, that is, you've got a web server. So you would click on the checkbox for web server, and that'll prompt up the window here to specify how you want to redirect web requests. So for external requests asking for port 80 information, HTTP information, we can redirect those requests to a particular internal computer. Say our internal computer .242 is a web server, perhaps running IIS, so it can handle those requests and respond back with port 80 requests for web pages. So what we've done here is a port mapping. Any incoming request to any of the 4 public IP addresses would be routed to an internal computer that we've specified. And for any port, you can specify a port mapping. So if you have an internal FTP server, again, click on the checkbox. It'll ask you, okay, to which internal computer would you like to route FTP requests? Now, if what you're trying to redirect, the port number you're trying to redirect, is not in this list, you can certainly add your own. So you just click on Add. What kind of service are we talking about here? We'll say Application X. And, let's say it uses a very odd port number, 1234. And we're going to redirect that to a particular internal computer. And we've just done our own port mapping. So port mapping is nothing more than specifying the port and specifying to which internal IP address we want to send that traffic to. Finally, the ICMP tab is very similar to Internet Connection Firewall. It has to do with what kind of ICMP packets will allow responses to and requests to. So for example, if someone tries to ping our NAT server, the NAT server will not respond. And in fact, the person that is pinging our NAT server will get an error message saying that the NAT server is not even available. The reply will time out. So if you say to allow incoming echo requests, for example, what you're saying is you will allow the NAT server to respond to ping requests. There's a variety of uses for ICMP, so a variety of things you can enable for requests or responses to requests, etc. So to sum up, there's two basic ways to configure NAT. One is to specify an address pool and reserve addresses. The other is to map ports.